So hi everyone, today we are going to learn one of the most important concept in programming, that was recursion. So see, recursion is not difficult. The difficult part is the way we think about it. So okay so we are first going to understand how recursion think. So see, suppose someone give you a problem to find a subset of 1 2 3 4. And now you look at the problem and think, I don't know how to solve this. That means you give up? No, a good programmer asks a smarter question. So the smart question is, instead of asking how do I solve the whole problem, we can ask like, can I solve a smaller version of the same problem? If the answer is yes, then you are already thinking recursion. Now what does mean? See, smaller version. So a good programmer asks, can I solve a smaller version of the same problem? So now what is mean by smaller version? Most see, um, suppose let's take this array only. Now I'm currently standing here. So I decide something. I'm not going to solve the whole array. Instead, I will let the remaining array solve the same problem first. So my new problem become like this: 2 3 4. Notice something carefully. Did the problem change? No, we are still finding subset, only the input becomes smaller. Now imagine two think exactly the same way. To say, I will let the remaining array solve the problem. Now the problem become 3 4. Again 3 also think like same, 4, then last empty subset. Every time the problem remain the same, only the input becomes smaller. So let's take another example. Maybe subset still feels new. Let's take another example. So find the sum. 10 20 30 40. So find the sum of this array. So now you think, I don't know the total sum, but suppose someone tell you the sum of 20 30 and 40 is 90. If someone told you the sum of 20 30 40 is 90, now you can find the total sum. Yes, I can find the total sum. So easy, we add 10 plus 90, that was 100. Again, did the problem change? No, we are still finding the sum, only the input becomes smaller. So see, let's compare both example and find the subsets. First 1 2 3 4, then 2 3 4. Same here also. In find sum, 10 20 30 20 30 40. In both example, the problem never change, only the input becomes smaller. So now what is recursion? See, recursion is a programming technique where a function solves a problem by asking a smaller version of the same problem to solve itself first. So very simple. See, recursion is equal to same problem plus smaller input. That's the entire idea of recursion. This is the entire idea of recursion. Same problem, smaller input. So see, but wait, if every recursive call keep making the same problem, let's see, if every recursive call keep making the problem smaller, like this, see, 1 2 3 4, then 2 3 4, then 3 4 4. So in last is empty subset. Will this continue forever, or does it stop somewhere? We have to stop it somewhere. So we need a stopping point. Okay, so see, let's take one more example. Imagine there are four friends. Okay, A has a doubt, so A asks B. So don't know the B also don't know, so B asks for C. Okay, same C also don't know, C asks for D. Same D also don't know, D asks for E. Now let me ask you, if what if D also no, see, if A don't know the answer, A asks for B asks for C, and C asks for D. What if D also asks someone? Obviously D asks for E, then E asks for F, then F asks for G. So on it's continue. Will this ever stop? No. Everyone is asking, nobody is answering. The same thing happen in recursion also. Okay, everyone is asking but nobody is answering. The same thing happen in recursion. Okay, so what do we need? We need a stopping point. Okay, so that we call a base case. So the stopping point is base case. So now what is a base case? See, the base case is the smallest possible answer. Okay, that we already know how to solve. Instead of making another recursive call, it immediately return the answer. So in here we know this is the smallest answer, so we return this to 4. Okay, now 4 return to 3. Like, wait, let me show you. Let's take small example. We have to find a subset. First 1 a step for 2, same 2 take for the. So this is our smallest answer, so this we call a base case. Okay, we are going to return this to 2. So to have received this, for every subset there are two choices, with and without. So this is also a subset. We take without 2, with 2. Okay, now 1 going to receive this 2. So for 1 also we have two choices, empty subset. We skip 1 or we take 1. Okay, the same for 2. Here we skip 1 and here we take 1. So this is our subsets. Okay, see for subset, what is the smallest possible input? Okay, so this is our smallest possible input. What are the subset of empty array? Here we are, array is finished, so what are the subset of empty array? The answer is this empty subset. Okay, so there is exactly one subset of empty array. There is exactly one subset of empty array. Okay, the empty array is subset itself. So recursion stop here. So this is our base case. So recursion stop here, and this is our base case. Okay, see, there are two phases of recursion. Now another important question is, what happens after reaching the base case? Okay, see, most beginners think recursion only goes downward. Actually, recursion has two phases. One is, there are two phases. One is going down, like A, B, C, D. Okay, while going down, nobody is solving anything. Every function is all only asking the next smaller app problem. Okay, here see, we are going down 1, 2, and this one our smaller. So second phase is coming back. Okay, like D, C, D, C, B, A. Okay, now the answer start coming back. D return answer to C. Okay, C use dot answer and return a new answer to B. B use dot answer and return a new answer to A. So finally A get the complete answer. Here we have done that. Okay, so it's going back. So see, the golden rule of recursion is, so every recursive program follow the same pattern only. The pattern is smaller program plus my work is equal to final answer. Okay, so see, first we get the smaller answer, then do your own work, finally return the new answer. That's it. Now what's next? So now we have understand what is recursion, what a smaller problem is, why we need a base case, the two phases of recursion. We have understand this all. So the next is so next we are going to really understand this. Let me, okay, see, can every recursive problem be written in the same way? So the answer is no. Every recursive problem is not going to return in the same way. There are three common recursion style. Okay, there are three common recursion style. Okay, first one is return based. Okay, and second one is include, exclude, backtracking, and third one is for loop, backtracking. Okay, so and in the next part we will run the first one. Okay, return based recursion. Now we are just, okay, now that we know the recursion can be written in different style, so today we are going to learn only first style, that was return based recursion. Okay, so return based recursion is, instead of learning the definition first, let's understand it with a simple problem. uh, let's see, suppose I give you an array like 1 2 and I ask you find the subset. Okay, before solving it, let's understand one thing. Okay, we want to know that. Okay, so what is mean by subset? A subset means you can take an element or you cannot take it, that's all for the array. See, for this array subset will become like 1 2 and 1 2. Okay, notice something, we never change the order, we only decide whether we to keep an element or not, that's it. So now see, suppose I am standing here. Okay, I don't know a subset, so what do I do? Instead of solving everything, I will use recursion. Okay, first give me all subset of remaining array, so my smaller problem become just 2. Okay, notice the problem did not change, I am still finding subset, only the input becomes smaller. Okay, now move to the smaller problem. Now I am standing here at 2. Again I still don't know all subsets, so I will do the same thing, I will ask the smaller answer. So the smaller answer is the array is finished, that was empty. Now we are reached the smallest possible part. Okay, this is the smallest possible input, there is nothing left, so recursion stop here. Okay, this is our base case. This is our base case. Base case, what are the subset of an empty array? There is only one, that is, so this answer is written back. Now see, now 2 has received this, it 2 has received this. Okay, like let me show you, 1 2, this is empty, now 2 are going to receive this. Okay, see, now think carefully, I already have one subset. Okay, I already have one subset, can I simply keep it? Of course, so my first subset is empty. But wait, my current number is 2, can I also create another subset by adding my numbers? Yes, if I add 2, then I get this. Okay, now look carefully, I am just from just one subset, I have created two subset. Okay, for from this one subset I have created two subsets. How? The first one I keep exactly as it was. Okay, the second one I added my current number. So 2 is my current number I have added. Okay, that's where these two ideas come from, without two and with two. Notice nobody told us to create with and without. We have discovered it naturally. Whenever a smaller subset come back, we always have two possibilities. Keep it exactly as it is, or create another copy by adding the current element. That's it, the entire idea of return based recursion. Okay, now 2 has received this, now 1 going to receive this and this. For 1 also we have two choices, we skip 1 or we take 2 1 2. So that's our answer. Okay, so this is the entire idea of return based recursion. Okay, whenever a smaller subset come back, we always have two possibilities. Keep it exactly as it is, or create another copy by adding the current element. That is the entire idea of return based recursion. That's it. So now 1 has received this 2, 1 has received this 2. So again I have followed the exact same thinking. Let me take the first subset, this. Can I keep it? Yes, I have keep it. Can I also create another subset by adding my current number? Yes, I can, for this one. Okay, now same for 2, same for 2 also. Okay, now look at the second subset. Can I keep it as it is? I have 2. Yes, I can. Can I add my current number? 1 2. Yes, I can. Now we combine them, it's look like this, 2. So this all subsets. Okay, see, every time a smaller answer come back, I do the same 2 step. So the step 1 is we keep every subset exactly as it is. Okay, keep every subset as it is. And step 2 is create another copy by adding current element. Okay, keep every subset exactly as it is and create another copy by adding my current element. That's it, that's all. Okay, so every subset always create two version. Okay, without current element and original subsets, and with current element plus original subset. Okay, now return based recursion formula, it's like this. Get the smaller answer for every subset, for every smaller subset, keep it as it is and create another copy by adding the current element. So return everything. That's it. Okay, now let's take very small example. So we have 2. Okay, let's start with the smallest non-based example. So I am standing at 2. Do I know all subset? No. So what will I do? I will ask for the smaller problem. So what is my smaller problem is empty. This is a base case. Okay, now we come back, like say 2, I will ask for the smallest. So the thing, now we come back. Okay, so I will keep it. So I will also make another copy by adding 2. So I will keep it exactly how it was and we keep adding our current element. That's it. So then final answer is this. Okay, that's all had to do. Okay, let's take another example. So it was simple. 1 2. Now I am standing at 1. I don't know all subsets, so I will ask the smaller problem. So it's look like this. I will ask for 2 to ask for empty subset. Okay, so this is our base case. Now 2 has received this, so we keep it and we keep it exactly how it was and we add 2. Okay, for this subset C, when it's received for 2, this subset we have two choices: keep as it is or and add current number. Okay, now 1 has received this, so see, current subset is empty, we keep it like this, and we for this subset we have two choices: 1, add 1. Okay, so this subset also we have two choices: 1, 2. So see, nobody generate this 4 subset directly, they will build little by little while coming back. Okay, now let's take one more example: 1, 2, 3. Okay, so how can we ask for smaller problem? 2, 3. So 3, then empty subset. Okay, so see, going down is easy, nobody is solving anything, everyone is only asking. Okay, now this is a base case, so 3 has received this base case. Okay, so we generate without and with 3. Okay, now 2 has received this 2, so 2 has received this. Now let me show you like this. We have numbers 1, 2, 3. Okay, first we going down 2, then 3, then base case. Okay, so now 3 has received this. For this subset we have two choices: without 3 and with 3. Okay, so now 2 has received this 2. For this also we have two choices: without 2 and with 2. So for 3 also same: without 2 just 3, and with 2 2, 3. Okay, now 1 has going to receive this all, so same for 1. For this subset we skip 1 and we add 1. For 2 also we skip 1, then we add 1, 1, 2. 3 also same: 3, skip 1, add 1, 1, 2, 3 na last one. 2, 3, skip 1 and add 1, 1, 2, 3. So this is our total subsets. Okay, see, can you see the pattern? Every function did exactly the same work. Okay, same work. So total I think 1, 2, 3, 4, 5, 6, 7, 8 subsets. Now wait, let's take one more. So we have 5 and 6 only. Okay, so if recursion give me this answer, okay, if recursion, I am standing here, I am asking for a smaller problem, now recursion give me this. Okay, so what should I return? What should I return? For this we have two choices: skip 5 and 6, 5, 6. Okay, I did not, so here see, I did not invent anything new, I simply repeat the same rule for every subset, keep it, make another copy with the current number. That's it. Keep this current subset and make another copy with current number. That's it. What is the final pattern? Smaller answer for every subset, keep it, create another copy and return everything. Okay, now see, now let's convert our thinking into code. Okay, so we only run one idea, ask the smaller problem for its answer, then build your own answer. Now let's teach this idea to computer, and we will write every line of code by asking one simple question: why do we need this line? Okay, if you know why, you will never have to memorize the code. That's it. So see, what is the first thing I need? Let's take example 1. 2 3. Okay, I am standing at 1. Okay, 0 1 2, so this is the index. I am standing at 1. Do I know all subset? No. So what do we decide? Earlier we said first bring me the subset of 2 3. Okay, first bring me the subset of 2 3. So see, now here is a question: how do I ask for a smaller problem in code? So how can we write nums? This is our nums, I plus 1, simply. Okay, see. Okay, see, this line, this single line represent our entire recursive thinking. Okay, I am telling the computer I don't know the answer yet, go to the next element, solve the same problem there, then you will done, come back and give me your answer. See, simple. I'm just telling I plus 1, and now this is our nums of array, and just go telling go I plus 1, to associate I plus 1, like this. Okay, so how can it's called? Let's take our function name is sub, call 0, then sub of 1, then sub of 2, then sub of 3. Okay, this is exactly the recursion tree I have drawn here. Nothing new happened, we simply translate our idea into code. Let's write down the code. Simply I just need, wait, first int main return 0. Let's make a vector 1 2 3. So I need a function vector in sub nums int I. So what we have done, we just so I need this. Okay, so let me write, I am telling the computer I don't know the answer yet, go to the next element. That's it. I don't know the answer yet, just go to the next element, sub nums and I plus 1. That's it. Okay, so see, now where will I build my answer? Now suppose recursion come back, now it's come back empty 3 and 2 3. Okay, it's come back and it's give me 0. Where should I store my final answer? So we need another list. Okay, so that's why we write 8 is it your vector int answer. Okay, so wait, let me create first variable here. Okay, now see here, so small contains the answer from the smaller problem. Okay, and an answer will contain my answer. So never fix this two, one is received and another is created. Okay, so because I'm going to return the answer like this subset, so that's why we are going to create a 2D vector. Okay, now do I need only one subset? Suppose see recursion has written this, so should I process only the first subset? No, I must process every subset. So how do we process every item in C++? A loop. Okay, so we need a loop for auto s to sma ls small. Okay, Now see, this loop simply says take one subset of a time. Okay, so first it's take this, then 3, then 2, 3, one by one. Okay, so now see, build up first, we have to build a first version. Okay, so suppose if yes is equal to 2 and 3, so what was our first version without the current number? Okay, so what does that look like? Exactly the same now. So we do not need to change anything, we simply say it, we simply say just ans dot push back s. Okay, we are not changing anything. This line means keep the old subset exactly as it is. Okay, ans dot push back s. This line says keep the old subset as it is. So this is our old subset, just pushed, and we are just pushing this into our answer variable. Okay, so now we have to build another version. So can I create another subset? Yes, this time I am including my current number. Suppose my current number is 1, so can I modify the old subset directly? No. Why? Because I am still need the original one, so I create a new subset. Okay, so I have to create a new subset with the in choice. Okay, so choice is a brand new subset, we will build it for scratch. Oh, that's it. Okay, now see, now we add my number first. So my current number is 1. So what the first thing we should put into the new subset? Obviously 1. So let's put choices dot push back nums of I. Okay, now how our new subset look like this. Okay, so now see, we have add everything from the old subset. Now look at this 2 and 3. How do we run 1 like 1 2 3? So in how do we run 1 into like this? So we simply copy every element. Okay, so let's copy every element. Yeah, I'll just copying. Okay, for int x is to s, then choices dot push back x. Okay, so it's look like this. See, now see choices is equal to 1. So in first iteration x is equal to 2, so now choices is equal to 1 and 2. In second iteration x is 3, so now choices become 1 2 3. Now our second version is ready. Okay, now we have to save the new subset. What should we do with this new subset? So we just store. Okay, store it. How can we store it? ans dot push back choices. We have to store this. Okay, now we have both version, without 1 and with 1 also. So it's look like this, without 1 2 3, with 1 1 2 3. Okay, exactly what we discovered during the run, same. Okay, now see, the loop now move to the next subset. Again I have created 2 version. Again I store both. This continue until every subset has been processed. That's it. In last we are just going to return the answer. Return answer. Okay, so see, I am telling my parent here are all the subset I created. Now it's your turn to build an even bigger answer. That's it. But wait, did I miss anything? Yes, a base case. When should recursion stop? What if I keep calling the smaller problem forever? It will never end, so we need a stopping condition. Okay, if I is equal to nums dot size, then return. This is our stopping point. Okay, when we have moved beyond the last element, the array is empty, and we already know the subset of empty array. So we already know the subset of empty array is this. Okay, so instead of making another recursive call, we simply return the answer. So that's our base case. Okay, let me tell you one line of the code. So see, and function sub, what they return all subsets starting from index I. So see, thinking as the smaller problem for its answer, build my own answer using the smaller answer, return my answer, that's it. So this is our base case. We have reached the beyond the last element, the array is, so the subset of empty array is this. Okay, now next smaller. See, give me the subset of 2 3. I'm asking here. Get the smaller answer and remaining array to solve the same problem we have repeated. Now the same only, and last we are just going to return the answer. So let me print this first. Okay, let's create result vector int result equal to sub nums and 0. Okay, generate all subset. So let's print for auto subset is RESU pushed into result. COUT. I think like this only. Then I have to for in x is to SQB SPP subsets, then COUT x EMDL. I think one problem with EM. Okay. See, so the answer is same what we have read in our recursion. It was not zooming. Okay, see, 1 2 1 2, where is our subsets 1 2 1 2. It is our total 8 subsets now. Let's create one new only. So we have 1 2 3. So 1 2 3. So the empty, they are going to receive this empty. Okay, so for empty subset we have two choices, without 3 and with the 3. Okay, now 2 are going to receive this 2. So first one is without 2, with 2, without 2, and with 2. Now 1 going to receive this all, without 1, with 1, without 1, with 1, without 1, and 1 2 3 with 1. Empty subset 1 2 1 2 1 2 3 1 3 2 3 1 2 3. Okay, so the answer is same. Wait, oh no, I think no, wait just Okay, so the answer is same. Okay, what we have done, this is our code. So see, now we have understand what is recursion. We also run the first style of recursion, that was return based recursion. Where is it? Okay, that was this. And most importantly, we have run its thinking. So we have run the thinking. Small answer, my work plus final answer. Remember, this is the entire idea of return based recursion. Ask the smaller problem for its answer, do your own work, and return the new answer. That's it. So have we really run return based recursion? Not yet. Why? Because understanding an idea is only the first step. If you cannot use the idea to solve the earlier problem, then you have not really run it. Okay, so now see, let's take this exactly thinking and apply it. LeetCode problem 78. We have not memorized the solution. Instead, we will start from the problem statement. Okay, think like a programmer. Apply the return based recursion idea we just run. Draw the recursion tree, do multiple dry runs, and finally convert the thinking into code. Okay, so by the end of this problem, you will not just know the code, you will know why every single line exists. And once you understand that, you will be able to write return based recursion on your own. Now let's solve this problem. Try by yourself also. Okay, now it's LeetCode problem 78 subsets. Now let's solve our first return based recursion problem. Okay, so the problem is, you are given an array of unique integer and return all possible subset in the power of set. Okay, so see, they are given, let me write down, let me clear this. Okay, so it's got problem 70 and we are given an array of unique integers. So the unique integer is 1 2 3. I have solved this earlier only. Now our task is to return all possible subset of this array. So wait, before we even think about recursion, let's understand the problem, because if you do not understand the problem, you cannot write the solution. Okay, so now let's understand what is meant by subset. A subset simply we have no, but see, subset means choose some element from the array or does not choose them. That's it, nothing more. Okay, suppose the array is 1 2 3. Let's see some valid subsets are like this. Take nothing, this is called an empty subset. This is also a valid subset. Okay, so now let's take one, only one, and let's take two. This is also a valid subset. This is also a valid subset. This is also a valid subset. 1 2 also valid. If we skip 3, it was still valid, and 1 3 also valid. We have skipped 2, then 2 3 we have skipped 1. This is also valid. Then 1 2 3, take everything. This, so this is also a valid subset. This all are valid subsets. Okay, so the important rule is, there are two rules. Okay, and rule number 1 is, you cannot choose any element or you can skip it. You can choose any element. Rule number 1 is, you can choose any element or you can skip it. And rule number 2 is, you cannot change the order. Okay, you cannot change the order, like 2 1 3 1 3 2. You cannot change the order. You cannot change the order. So that's it. We can write 3 1. No, we cannot write 3 1 also. Okay, why? Because the original array is 1 2 3. So its valid array is 1 and 3. Okay, valid subset is 1 and 3, but 3 and 1 is not valid. Okay, so see, a very important observation is, now look at carefully. For every element, how many choices do we have? Take it or skip it. We have only two choices, take it or skip it. Okay, only two choices. For one, take it or skip it. 2 also take it or skip it, 3 also take it or skip it. Okay, so every element give us exactly 2 decisions. So this is the real problem. So if every element has only 2 choices, so our real job is simply to generate every possible combination of these choices. First take 1, take 2, take 3. So result look like this: 1 2. If we take, and if we skip 1, skip 2, skip 3, so result 2 3. So skip everything, so the result is like this: empty, and 1 2 3 also. Now see, now come the main question is, we completely understand the problem now, but how do we generate all this subset? Can we solve this using return based thinking we just run? Let's find out. Let's write. Now let's take same example: 1 2 3. I am standing on here. First I am standing at the first element. I am standing at the first element, which is 1. So do I know all subset? No. So what should I do? Should I try to solve everything myself? No, I will use the idea we just learned. So remember, recursion says do not solve the whole problem. Ask the smaller for the help. Ask the smaller problem for the help. Okay, so can someone solve a smaller version of the same problem? So the smaller problem is 2 3. Okay, if someone give me the subset of 2 3, I can build subset of 1 2 3. Yes, see, notice something. I'm still solving the same problem. I'm still finding the subsets. I only need the small input smaller. Okay, the only made the input smaller. Now we move to the next call. Now 2. So 2 says now recursion is the second element. So those 2 know all subset? No. 2 also think exactly like 1. It says I am also not going to solve everything. First give me the subset of 3. Okay, if someone give me the subset of 3, I can build subset of 2 3. Okay, so 3 says now we am standing at 3. Those 3 know all the subsets? No. So what those 3 do? Exactly the same thing. It says give me the subset of the empty array. If someone give me the subset of empty array, can I build subset of 3? Yes. So the base case is, this is a base case. Now there are no element left. Can I make the problem any smaller? No. Okay, this is the smallest possible problem. This is our base case. Okay, this is our base case. Now see, what are the subset of empty array? Subset of empty array, this. Okay, so there is only one subset, the empty subset. So recursion does not make another call, it simply returns this answer. Okay, going back now, something is very important happens. So far nobody solved anything. Okay, nobody has solved anything. Everyone was only asking the smaller problem, but now the answers start coming back. Okay, now answers start coming back. It's coming back. Now every function will do its own work. Let's start with 3. So 3 has received this. Okay, so 3 says 3 got one subset. Now see what can 3 do with this subset. There are only 2 possibility. First possibility is, okay, do not use 3. Okay, first possibility is these, do not use 3, keep the subset exactly same. And the second possibility is use 3. Okay, add it to the subset. So the result written by 3 is empty and 3. Okay, so 3 has done, it's returned these two subsets to 2 subsets. Okay, it's written these 2 subsets. 3 has going to return this 2 subset. Now 2 has received this 2 subset. Okay, 2, now it's 2 run. It will process every subset one by one. So the first subset is without 2 and the second subset is with 2. Same second subset without 2 3, with 2 2 3. Okay, so it's like look like this: 2 3 2, 3. Okay, so notice what happened. Every old subset produced two new subset. Okay, now one has received, one going to receive this all. Okay, so now one repeat the exactly same idea. First subset without one with one, second for 2 without 1, 2 with 1, 1, 2, same for 3 without 1 with 1, same for 2, 3 without 1 and with 1. Okay, so see, did you notice something? Nobody tried to solve the whole problem. Each function only asks for the smaller answer, then the answer come back. It simply create two version of every subset, one without the current element, one with the current element. And that's exactly why this style is called return based recursion. That's it. Let's write down the code. Victor and sub I. So okay, return all subsets starting from index I. Next we need a base case. If no element left, the only subset of empty array is, we need a base case. If I is equal to nums dot size return empty. Okay, then we need a smaller answer. As the smaller problem, give me all subsets starting from next index. Okay, for this we are going to write, let me write this. Come on, see. Smaller problem, sub nums and I plus 1 starting from next index. Okay, give me all subsets starting from next index. Next build my answer. Come on, we have to build my answer. Next, process every subset. Okay, we have to process every subset. For auto for auto, yes, for auto small. Okay, then without current element, keep the subset exactly as it is. That's why we are going to push answer dot push back s. Okay, second is with current element. Int choice. No, copy all. We have to copy the, yes, wait, choice dot push add current element. Okay, we have to add the current element also. Then for int x to push back x. Then we have to save the new subset. Return return a and s. return sub nums and 0. Yes, it's done. So see, when do I stop? If I is equal to nums dot size, then return. How do I get a smaller answer? That's how we get a smaller answer. Where do I build my answer? Here. Okay, here I build my answer. How do I use every smaller subsets? How do I create two versions? Answer dot pushback and choices nums of 5. Okay, so next is, let me submit this. It was correct. Yes. Now see, so the time complexity is, for every element we have two choices: include it, exclude it, means skip it or take it. If there are n elements, the total number of subset is 2 into 2 into 2 into so on, so n times. So n 2 square 2 to the power n. Okay, also creating each subset may require copying up to the n elements, so the time complexity is big O of n into 2 to the power of n, and the space complexity big O of n times 2 to the power of n. Okay, and the space complexity is, the recursion goes at most n levels deep, so the recursion stack use big O of n. We also store all subset. There are 2 to the power of n subset, and each subset can contain up to n elements, so output space is big O of n into 2 to the power of n. So the final, see, let's write a final. Recursion stack is equal to big O of n, output space is equal to big O of n into 2 to the power of n, overall space is equal to big O of n into 2 to the power of n. Okay, so what did we learn today? Today we did not just run a piece of code, we have run a completely new way of thinking. Recursion does not try to solve the entire problem. Instead it says, give me the answer of the smaller problem and I will use that answer to build my own. Okay, that is the heart of recursion. That's it. And what is return based recursion? Return based recursion follow a very important pattern, that was get smaller answer, do my work and return the new answer. Okay, get the smaller answer, do my work, return the new answer. Okay, every recursive call follow the same idea. It trusts the smaller recursive call, build its own answer and return it. That's it. So recursion does not solve whole problem, it solves a smaller problem, does its own work and return the answer. That's it. Let me write in green. Same problem, smaller input, my work and return answer. Okay, so today we run what recursion is, how to think recursory and how return based recursion work. Okay, so we also solved our first LeetCode problem using this style. So we have also solved this problem using this style, but there's the interesting part is return based recursion is only where writing recursive solution. Okay, so the same LeetCode problem can also solve using a completely different recursion style, and that exactly what we will run in next lecture. So we will study the second recursion style, that was include and exclude backtracking. Okay, and solve the same problem again. We solve the same problem again by using style 2. So that's it. By learning multiple recursion style, you will start recognize which style fits which problem, and writing recursive solution will become much more natural. That's all.